doesn't work. So they needed to come up with another name. And basically they didn't seem to come up with another name, so they just called it ECMA, which stands for European Computers Manufacturers Association, script. It's a stupid name in my opinion, but that's what they did. So ECMAScript is basically JavaScript, but the standard version of it, okay? But they're the same thing. So if you ever hear ECMAScript, it's JavaScript. It's the same thing, all right? Okay, so how do we actually run JavaScript, right? Well, there are different ways to do it, but the way that I encourage you to do it now for this class at the beginning is through HTML. Now, again, the first assignment was to learn HTML, so hopefully you guys understand that part. So just like in HTML, you have these elements, right? These tags that have an opening tag and a closing tag, right? You can have a div, you can have a p, right? You can have a span. In the same way, you can create a tag called script. And then inside of that script, you can put JavaScript code. And when the browser is reading your HTML, it's saying, I need to draw an H1. I need to draw an image. I need to do whatever. When it gets to the script, it understands it needs to execute the code inside of that script. So if you put code inside of your script tag, the browser will run it, execute it. And again, what do I mean by running it? It will read the code that you wrote, eventually go through a process of turning it into zeros and ones, machine code, run it on the processor, and you get your program. Okay? A second way to do it is to again use the script tag, but in this case, instead of putting your code directly inside the script tag, you make a reference to another file. So you write your code in a separate file where you put JavaScript. Now you remember from last time that files have an extension, like a dot something. And that dot something kind of tells us what kind of file it is. If it's a .txt, it's a text file. If it's a .csv, it's a comma-separated file, right? If comma-separated values. If it's a .doc, it's a Word file. It's a Word document. If it's a .java, it's a Java file. What do you suppose JavaScript extension is? JS for JavaScript. So some name .js is the name of your JavaScript file. You simply reference it using the src or source attribute. And what the browser will do is it will go download the JavaScript file and run it. In the same way that image works. If you recall from an image tag, you have img, then you do src, the source, and you say what image to render inside. So what does the browser do? When it gets to the image tag, it reads, oh, I have to go download this image. It goes, downloads the image, and then draws it. With script source, it goes and downloads the JavaScript and runs it. With me so far? Cool. Okay, so let's go through the exercise of actually creating an HTML file with script, which is kind of something that you're going to be doing for your homework, actually. So let's make, hang on, let me, okay, so imagine you're creating a brand new file, right? This file is just brand new. You put in basic HTML in there. This is hopefully something that you guys are familiar with, right? The head, the body is the stuff that gets rendered. Head is just general metadata about the document. The title, what you put in here is the stuff that you see in that tab. You know in Chrome, every time you open something, you have like a little tab up there? The title is the text that appears there. Yeah? Okay, so that's the title. And then here's where we put our HTML. So let's make a very basic document with an H1. And let's just put, you know, hello world or something. Hello AUA. I like that one better. We save it. It's a file, right? I mentioned again that files have extensions, these dot something in their name. That tells us what it is. What is the extension for an HTML file? POM, good. Okay, so on my desktop, I will store some file. Let's call it, you know, app or AUA.html, right? So that's the name of the file, and that is the extension of the file. Save. Boom. I now have this file somewhere on my desktop. So now if I go to my file browser and I go to my desktop, Here I should see somewhere, where is it? AUA, AUA.html. You see that? Notice the icon. You see this icon? It's got like a picture of a browser in it. The way the operating system knows to put that icon is because of that file extension. Let's try an experiment. Let's change the file extension. Oops, sorry, I double-clicked on it. Sorry, 1 second. Let's change that to some .txt. Use text. Notice the icon changed. Interesting. So now if I double-click on it, the operating system is going to say it's a text file. I need to open a text editor for you to view it. So if I double-click on it, what happens? I get a text editor because it's a text file, right? But let me change it back to an HTML. Use HTML. And the icon changes. And now when I double-click on it, what's an application that knows how to draw HTML? Your browser. Your browser knows how to read a file with .html and then draw it on the screen. So when you double click on it, it opens up my Chrome and it renders the stuff, this stuff, on the page. Got it? Okay, so now we want to run JavaScript. Remember, we create a script tag, right? And in the script tag, we put in some JavaScript. You don't have to know what I'm writing, just this is JavaScript. Yay. Okay? That's JavaScript. So now if I refresh, I get this dialog that says yay. So you can see it ran the JavaScript, right? It ran the code. It executed the code. So if something told the processor, go. Here's the information, here are the instructions, go. And then something happened, and that something resulted in a dialog rendered on this page. Yes? Okay. The other thing I can do, in addition, instead of just putting the code directly into the script tag, is to create a separate file. And this is always a good idea. You always want to separate your JavaScript code from your HTML code. So what we'll do is we'll create another file. Let's call it, let's save it and call it, AUA.js on my desktop. Okay, and here let's put the alert yay in here. So again, right, this is just JavaScript code inside of a file called AUA.js. Again, the JS tells the operating system, hey, this is a JavaScript file, right? Okay, so then in here, in our AUA HTML, we can refer to that file. So we create a source, src, reference, and we specify the path, how to get to that file from where we are. Now, both this HTML and the JavaScript are both saved on my desktop. So they're both starting from desktop. So from desktop, I simply need to specify the name of the JavaScript file, and it will find it. So I just write AUA.js. This is the name of the file that I want to load and run. I save it. I go back here, and I refresh, and I get yay again. Right? Except this here, just so you know that it's actually doing it, let's say, woo, AUA, okay. And now if I refresh, woo, AUA, okay. So, again, the JavaScript is in a separate file. The HTML is in a separate file. The JavaScript is being referenced from a script tag inside of my HTML. This is how I want you guys to write JavaScript from now on. Okay? Don't put JavaScript inside of the script tag. Refer to another file. All the homework assignments that you submit, your JavaScript should be in a separate file. Don't put it in the same place. You can do it if you're just trying something, but when you're actually submitting a homework assignment, put it in a separate file. Okay? Yes? Any questions so far? Anything that, yes?
What is that message or set?
What is, let me go back.
No, this.
Oh, sorry. This thing. This is the, okay. Actually, this is optional in this case. This is saying that the file character set should be, it's a standard. UTF-8 is a standard of how characters are defined. And it's saying in this file, I want to use this. For now, in your homeworks at least, you don't even need that. In fact, you don't need this either. That is all you really need. And by the way, this title, remember how I said it's the stuff that appears at the top? Let's write haha and refresh. See how up here you see haha? That's the title. Yeah, that's how you control that. Other questions? Wait, go.
Is it right to put the script code in the head?
Okay, good question. So the question is, what if you were to put the script tag in the head? Why am I putting it in the body? And specifically, why am I putting it at the bottom of the body, right? That's your question. Okay, in general, when you write web applications, you always want to put your script tag at the end of body. Why? Let me explain. If I put it here, so one of the reasons why you want to add JavaScript to your website is to control the DOM, the HTML, right? You want to modify something or whatever. The problem though is that this, if I put it here, will run before the DOM is fully created because it executes top down. So it will run the script before it has read and executed all of this stuff. So if from here, let's say this is actually script. This is for those of you who understand. If I do, document.get element by ID, and I want to refer to this element, which has ID of whatever, A, and I do A here, this won't work because this does not exist yet. Oh, right, sorry. Wait, what? Oh, sorry. Yeah. Because this element does not exist yet. If I put it here, exactly, because H1 ran, it rendered, right? Then this ran, and now it's referring to that thing. Yeah? So generally speaking, anytime you write JavaScript inside of HTML, put it at the bottom of your body. Just have it be the last thing inside of your body element. Okay? Yes, sir.
When we save that HTML file in JavaScript file in our desktop and then send that code to another computer, it will not work, yes?
Okay, so let me explain what you just said before I answer. You want to generally, when you create a project is like a directory, right? In your case, you said desktop, but generally, like when you do your homework assignments, you're going to create a separate directory, call it homework 1 or something, right? Inside of that is where you'll put all your stuff, your HTML, your CSS, your JavaScript, all that stuff. The reference that you put here, wait, 1 second. This is the name, how to get to that file from where you are, right? It's called a relative path. It's a path relative or starting from where we are. If I were to instead do something like C colon users, Ruben, Meschan, desktop, if I were to do that and send it, it would not work for you because on your computer you don't have Ruben, Meschan on C, right? This is called an absolute path. It's a path that starts from the very beginning of your file system, from C, right? So instead, I give you a relative path, a path that is just relative to this file. The nice thing about this is if you move the entire directory, it's still going to work because JavaScript is still next to the HTML, right? So all you have to do is just take that directory and push it to Git. And when we get it and we double click on the HTML, it will run your JavaScript. Yeah, I answered your question? Cool. Other questions? Yes?
What program is this? Will it work with any kind of notepad or
So programs are just text. Any program that you see, whether it's C++, Java, it's just text, which means you can edit it using any text editor. You can use it with Notepad, this is Sublime, different editors. But some editors do things like syntax highlight. See how like the tags are red here? This is called syntax highlighting. It helps you code. It makes it easier to see the code and understand it. Some editors do this for you. Some editors do not, right? It's up to you which editor you use. I recommend probably Notepad, maybe not. There's Notepad++ for those of you, maybe use that. Sublime is a fantastic editor. There's Atom. Those are good editors. Those are editors you want to be coding in. But at the end of the day, it's just text. So any text editor will work. Okay? Good question. Other questions? Okay. So we understand how we can run JavaScript, right? You create an HTML file, you create a script tag, you reference your JavaScript file, and you double click on the file to run it, right? It will open the browser and execute everything. Huh?
The JavaScript, can you show it?
Yeah, of course. It's this. That part is clear, right? Okay, so if I told you, like, go run this piece of JavaScript code, you would know how to do it? Yes? Okay, so let's move on. Oh, wait, not this. What happened to my... Okay. Okay, now, what have I done? I created an application inside of the browser, okay? What I did was I put in this editor that allows me to write JavaScript. What it does, actually not just JavaScript, any HTML. And what it will do is, as I change it, it will basically run that HTML down here. Why do I do this? Because showing you JavaScript by constantly like going to a JS file, changing it, going to the browser, showing the result, just seemed too difficult. This is just easier for me to show you what's happening, right? So the proper way to run JavaScript, again, is to create a separate HTML file, reference a JavaScript file, run it. But for me to explain JavaScript, I will use this application that I wrote here. Okay, so in case you're wondering, wait, what is this? That's what that is. It's just an editor, and anything that I write in here will run that down there. It's a program that I created, just so it's easy for you to see what's happening. So imagine this is the browser, and that's your editor. Okay, fine? Okay. So let's actually dive into code. Let me zoom in a bit so you guys can see. Okay, so the first thing, just know that if you ever write console.log, just that, don't worry about what that is for now, but when you write that and you open parentheses and you give it some sort of a value, it will print it in your console. Now you might wonder, what is a console? Okay, in this application, the console is this thing down here. But when you run your applications, let me go back and run this guy, AUA HTML, this guy. Let's, instead of alert, let's have it do console.log. Save. Okay, now when I run it, nothing happened. Where is it? Well, let me explain. Right-click and go to inspect. And you will get this development environment where you can kind of see the HTML. This is the HTML, by the way. Here, let me zoom in. So you can see the HTML that I wrote. Look, there's an H1, there's a source, blah, 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 right? In your console, you see this? Wait. Oh, sorry, custom. Sorry. Wait, one second. Not hide all. Yeah, let me do default. Okay, there it is. Sorry. Okay, so this tells you which, because you can also console error, console warning, console whatever. Console log, there it is. It's written in your console. Why do we write things to the console? A lot of times it's for debugging. If you don't know why your application doesn't work, you can print a few things and you can kind of see what's happening in your application. That's really why it is. It's not for showing things to the user. It's for developers. Okay? So console log will write any value that you give it to the console. Fine? So if we go back to the app, where's my app? There it is. If I do console log 110, it will print 110. Yes? Okay. Now, let's dive in. Now we have understanding of how to run JavaScript, and we know what console log is. Let's actually get into the language. So the language of JavaScript has values, like numbers, like text or strings, right? It has a notion of Boolean, true or false. So in this case, for example, an example of a number, of course, is 110. And I can just console log 110 and it will print 110. We also have Booleans, true or false, and we have strings. There are two ways to create a string. You can use single quotes like this, ABC. There, that's a string. Or you can use double quotes like that. Both of these will make string, text, if you will. So in this case, I'm printing the text CS110. There it is. Now, if you ever want to know the kind of thing that a value is, you can use type of. Type of will tell you what it is. So the type of this thing is a string. The type of a number, like 99, is a number. The type of a Boolean, like true, is a Boolean, right? So in this way, if you're ever curious about the kind of thing that a value is, you can use type of and it will tell you what it is. With me so far? Okay, so far nothing complicated, just we have values, numbers, strings, and Booleans. There are other values that we will discuss, but for now, just know these. We have arithmetic operators. Nothing you don't know. You know all this. We have plus operator. We have multiplication operator, divisor. Divisor would be that one, right? Addition and subtraction, right? So again, nothing you don't know. And again, it follows the same mathematical rules, right? Order of operations. So if you want the plus to execute first, you put it in parentheses. It's just math, people. You know this. Nothing complicated here. This is interesting. This is text, right? With a plus operator and a number. Oh, that's weird. Bless you. So a plus means add two things together, right? So if you have two numbers, 1 plus 1, it should give you 2. Okay, but in this case, it's not a number. It's a text. Well, it turns out that the plus operator is overloaded. What I mean by overloaded is it does more than one thing. If it's got numbers on both sides, it will add them together. Fine. But if it has text either on the right side or on the left side, it will concatenate them together. It will stick them together and produce a new text. So, in this case, I have text on my left side and a number on the right side. The result of this is the text CS110. Make sense? Okay. If I do a multiplication, so a multiplication expects numbers. You can only multiply numbers, right? So 3 times 3, 9, no problem, right? So if I were to have here, 6 times 6, 36, no problem. But I'm multiplying with a string. You're not allowed to do that. Like, you can't multiply something that's not a number. So the result of this can't be a number, right? Because it's an illegal operation. So the result is nan, which stands for not a number. So the result of this basically is an error. Except instead of just stopping your application, it simply returns a value, which is nan, not a number, right? Okay, one thing you should know about nan is that nan is not equal to anything, including itself. What? Let me explain. We know that 8, the way you check if something is equal is by using that, 3 equal signs. Just bear with me. I'll explain later why. 8 is equal to 8, right? True. Fine. The text high is equal to the text high. True, fine. Let's see, true is equal to true. Fine. I am equal to myself, you are equal to yourself, the world makes sense, yes? Watch this. False. Huh. Remember how I mentioned that Brendan Eich implemented JavaScript in 2 weeks? This was one of the errors that he introduced into the language, right? Is that nan isn't equal to anything, even itself. So if you ever want to check, is a value nan? You can't just say, is, let's say, this nan, because it's always going to give you false, even if it is nan. So the way to do that is to use this is nan thing. It's a function, we'll talk about functions later, but basically you say is nan and you give it some value. And if that value is nan, it will return true. If it's not, it will return false. Which is why if I do CS multiplied by 100, that ends up doing this, right? Turns it into nan. And then is nan will return true. A number that is not nan, like a string, will return, wait, what? Okay. A number that is not nan will return false. Fair? Yes, good. Okay, let's keep going. So far we understand that we have values, like numbers and text and booleans, and we can do math. Yay, Facebook, here we come, right? Can you write Facebook so far? Probably not, right? That's not enough. Okay, so let's keep going. Okay. So I mentioned this triple equals thing, right? Equal, equal, equal. Okay? This will make a comparison. And it will produce a Boolean, which we know. It's either a true or a false. So is 1 the same as 1? Is 1 equal to 1? The answer to that is true, right? Is 1 not equal to 1? No, of course it is. So that's wrong. That's false, right? So we get false. Is 1 less than 2? Yes. Notice if I want to less than or equal to, in math you do this with the line under it, right? Well, in programming, because of the characters, what you end up doing is less than and then the equal. This is the same thing as saying less than equal to. Yeah? The other way goes the other way. Greater than or equal to. Fine. Or greater than, less than. This means not. Okay? Whenever you see this, it's like no. So not equal to. Equal to, not equal to. Equal to, you get the idea. Right? Okay. And the result of all of these is going to be a Boolean value. That is to say, a value that is either true or false. With me so far? Questions so far? Yes, sir.
If we write 3 equal signs, it also measures the type of 2 variables.
Yes,
right?
yes. So in
if we write 2 of them, maybe the string and the integer will be...
Exactly, which is why we don't do that. Yes, exactly. But again, remember, so there are lots of nuances of why I'm showing you triple equals instead of double equals. Just learn it this way. If you see double equals, so sometimes, for those of you who don't know, you could do this. This would work. But don't do that. I'm not teaching you that. And I'm not even teaching you why. Come to office hours, I'll tell you later. Do this. Okay? So this means equals, this means not equals. Okay? Cool. Other questions or concerns or comments? We're good? Okay. By the way, just FYI, you guys can ask questions in Armenian. So if you feel like you're having trouble explaining your question, say it in Armenian. It's okay. All right. Okay. This is where things get interesting. What is this? It's a box. And another box. Why do we have boxes? To put stuff into them. Yeah? Okay. So let me put something in here. What can I put in here? I know. I'll put this green thing into this one and the red pen into this one. There. I now have 2 boxes. Which box has which one? Exactly, who knows? Maybe I shuffled them, maybe I didn't. You don't really know. So what might make sense is if I labeled them. If I gave them some sort of an identifying name, that would make it easier for you to know which is which, right? Okay, that one doesn't stick. Okay, cool. All right, so let me write red, or R for red. Stick it here. Okay. And let me write another one, G for green, and let me stick it there. Okay. Which one has the red?
Green one.
You get the idea, right? So I can use these boxes to put things in, and so I don't forget what I put in each box. I give it some sort of a name, right? And it would be a good idea that I gave it a name that kind of said what's inside, right? Instead of putting R and G, or red and green ideally, what if I were to just call it like foo? By the way, foo bar is just like, it's something that programmers often say when they don't know what to name something, right? So let's just call it foo. Let's stick it there. And let's call this one bar. And let's stick it there. Foo, bar, zoo, you get the idea. Okay. So now, if later, okay, now you're kind of following me. Imagine you leave the room and you come back, and I show you these. You don't know which is which, right? How do you know what foo is? You don't, or you forgot, right? Or you leave and someone else comes in and looks at it. How are they going to know what's in here? Difficult to know, right? So naming matters, and it's a good idea to name things properly so that when people look at your box, they understand what is inside. With me?
I don't want them to understand it.
Well, okay. For now, let's assume we want them to understand it. Okay? So you put a good name to match the contents of the box. Yes? Okay. So in programming, we have an understanding called variables. Okay? A variable is one of these boxes. A variable has a name that you use to refer to that variable, right? So if you're ever curious, I want to use variable foo. That would be this one, right? What is a variable for? The same thing as what a box is for. You put stuff in it. What can you put in variables? Well, all kinds of stuff. We talked about some values that exist in programming, like numbers and booleans and strings, right? These are the things that you can put into these variables or into these boxes that have names, right? So now let's look at code. In this example, I have a variable called a. This is the name of the variable. A doesn't really tell me much because a is just a letter. Why don't I instead give it a name that makes more sense, like greeting text? Okay, now I understand what is inside. It's a text that greets you, yeah? And I put into it, so a single equals operator means put inside. Remember the triple equals, equal, equal, equal? That's how you ask if something is equal. If you want to assign a value or you want to place a value into a variable, you want to put the value into the box, you use equals. So again, this is the name of the box or the variable. This is the assignment or me putting something into the box. With me so far? The way I know that this is a variable is with this, const. Const is short for constant. What do I mean by this? What I mean is once I've put something into the box, I can't then change what's in the box. I'm not allowed to take it out and put something else in its place. Once I put the stuff into the box, I'm done. Still with me? Okay, so now this box is basically a name for the value. It contains the value inside. And I can use it. So now I can print, just like I could print, hello world. and here I would get hello world, I could print the box. And I still get hello world. Why? Because you can think of this as a name for the value that you put into it. So whenever you see greeting, you take the value that it has in your head and replace it like that. Let's look at some more boxes. So let's say we have, here, let me get rid of that. Let's say we have some numbers. Const, num1 is 1. Const, num2 is 2. Okay, so now this is a name for that, and this is a name for that. And we console log num1 plus num2. 3. Again, in your head, remember that num1 means 1, right? It's a name. It's an alias for 1. So just replace it in your head with 1. Num2 means 2, so in your head, again, replace it with 2. Add them together, you get 3, and then it logs 3. All of that, what I just did, is what the computer does for you underneath. With me so far? Now, suppose I may turn 2 into text, like that. When I close this parenthesis, what will I see in the console? 12. Why? Remember, the plus operator, if it has text on either side, it will stick them together. It will concatenate. So in this case, it's taking 1. It's taking the text 2. Ask a question. Is there text on either side? Yes. Stick them together. When you stick them together, you end up like this. With me? Yes, sir.
When we are executing the program, it first turns everything into binary and after does the operation, or it does operation and only in the final part it turns everything in binary.
Okay. When you say does the operation, right? Let's walk through what you have. Okay, so the question was, do the operations happen and then things turn into binary, or do things turn into binary and then operations are performed, right? That was your question. Okay, so let's follow this. When you say operation, what do you mean? Like the mathematical operation?
Yes.
Okay. What do you need in order to do math if you don't have a brain? What part of the computer does math? Right. What language does the processor understand? Okay. So the answer to the question is this stuff first has to get translated into machine code so that the operations can be executed. Because executing or processing is by definition the job of the processor. That's what it does. It processes, it executes. Okay? Good. Other questions? Okay, this is clear. Okay, good. So we understand variables. We understand that there are these containers that you can put stuff in. We understand values. Simple ones are like numbers and strings and booleans. And we understand that we can do math. Addition, subtraction, multiplication, division. And that it follows the same rules in mathematics, right? If you do plus first, then multiply, it will do the multiply first, then the plus. All the same rules apply. Cool? Okay, let's keep going. Okay, when you name your variables, so notice here, the variable has a name, right? Like num1, num2. Remember the thing we had with the box. You always want to give names that make sense. Don't just call it okay, or A. Like a lot of people, especially students, I notice, they'll name their variables like A, B, C, D, E, F, G. Don't do that, because what the crap is Z? Like, how would I know what Z is, right? How would anyone reading your code know what Z is? Don't do that. Give it a name that makes sense. It has to match the stuff that's inside it. If you're putting text that greets people, write that that's what it is. If you're putting a number that you're going to use to add, right? That's what it is. So that when someone reads the name that's used in your code, they already know what it is. They don't have to go find where you put something into it and guess what that means. For example, if you want to specify the age of a person, right? Age is a number, right? So let's say you're putting in, 21. Don't call it A, call it age. So when people see it, they go, this must represent age, right? They don't have to go and say, okay, I have a Z equal to 21. Like what is Z equal to 21? But if you say age is equal to 21, now it makes sense. Okay, age, tarik, I understand that. 21 is a number, okay, so it makes sense. It's 21 is the age of whatever it is that we're talking about. So naming is very important. There are a few rules though in programming, specifically in JavaScript as well, of how you can name your variables. First of all, you can't have spaces. You can't say, my happy variable is, right? This is not a valid name. You're laughing because I think you intuitively understand that maybe this is not a good idea, right? A variable has to be stuck together. One way to do this, if you want to write something long, is you can underscore, right? You can do this. Now it's like one thing. Another way, though, which is more common in the JavaScript world, is called camel casing. Camel casing, well, just imagine a camel with the humps, is the first letter of each word starts with a capital. Happy variable is. This is called camel casing, okay? Fair? You can't lead with a number. So you can use numbers in your name, but it can't start with a number, right? So notice, like, it gave an error. I'm not seeing anything in the console. There's an error now. I can't do that. I can use it after, no problem, but not in the beginning. A lot of the rules that I'm telling you, by the way, are applicable to most programming languages that you will use, whether it's Python, Java, C++. Most of those generally follow the same rules as far as naming variables. You can't have spaces, you can't lead with numbers.
And can we do just lines, not underlines?
You can do, you can't do this.
Yeah.
Because this means minus. This means plus, right? This means multiplication. So you can't use arithmetic operators, right? Why? Because it will think that what you want to do is multiply this times this. It will not understand what you mean is this name. Make sense? Same thing with subtraction, addition, all the operators, right? You can't use an operator inside of your name. Intuitively, as you guys start programming, you'll begin to notice, oh wait, I named it this way, it caused an error, I should change it. So it will just take time, but I think you guys can figure it out. Generally speaking, names should generally start with a letter. You can do this, or even this. Just don't. For now, don't. Don't worry about that. For now, just always start with a letter. Okay? If you want to put a number later, go ahead. But for now, start with a letter. And in JavaScript, generally, we don't use this. We use camel case. So just do that. Okay? Yeah. So we can name values. That's okay. That's cool. What else can we do? Okay. So Boolean operators. Huh? What's a Boolean Have you guys studied Boolean operators?
Yeah.
Okay. Okay, I noticed some and some, yeah, okay, so, okay. All right, so what do I mean by Boolean operators? Basically, there are three that we're going to study. The first one is AND. AND in JavaScript is represented with two ampersands, like this. You just put them next to each other, it means AND. Okay? What it's saying is that if the left side is true and the right side is true, then the result of all of this is true. If either side is false, or if both sides are false, the answer is going to be false. With me? Yeah. So AND is an operator that sits between two values. Okay, so I'm the AND, I got... If they're both true, the result of all of this is true. If either one or both of them are false, the result of all of this, after computation, is false. With me? Just like the result of 1 plus 1 is 2, the result of true and true is true. The result of false and true is false. The result of false and false is twin. Okay, as I mentioned, if both sides are false, the result is false. I think that's also okay, right? What about this? What do you think? Okay, everyone's saying false. So first let's do this one, because we go left to right. What is the result of this is false, right? So then false and true is false, right? So the result of this would be false, right? Okay. Okay, this, so before we had and, yiv, right? And. Or is represented using these two things. Boom, boom. Pipes, if you will. What is it? Gangnag. Gangnag nerov. So what this is saying is, it's true as long as at least one of the two sides is true. Or both of them are true, that's okay, that's also true. So the only time it's going to be false is if both sides are false. So, one side is true, so it's true. Right? Both sides are false, only then is it false. Fine? Tell me. Okay. What is the result of just this part? True, right? Because for it to be false, both have to be false, right? False or false would be false. But false or true is true. So true, so false or true. True, because one of the sides is true. Which is why we get true. Yeah? Okay, let's mix it up. I'm sorry, did you have a question or you want to answer?
What would happen if we want to put a parenthesis?
A parentheses?
Does it change anything?
Yeah, it changes order of operations. Just like in math, you know, you use parentheses to say like do this first, then do that. Yeah? Same thing here. So yes, it could theoretically change something, yeah. Because you might, if you go left to right, it might be different from if you do this one first, then do that. Do you kind of see it? Okay. So in this example, what happens? Okay, so the result of this is true. So true and false. Remember, and what do you have to do for it to be true? Both sides have to be true. But look, this side is true, but this side is false. False. Cool. What about this one? Okay, so this part is false, right? This part. So that's false. So it's true or false. Remember, for or, one of the sides has to be true. That's this side. So the answer is true. Yeah? And this one? Oh, sorry. Okay, so far we studied and we studied or. Remember that this means not. Remember, even when we were doing the equal sign, we did equal, equal, equal to see if it's true, and we did exclamation point equal, equal to say not true. You remember that? So this is very often used to mean not. So it's the opposite of that. It's you flip it. So if you flip true, you get false, right? If you flip false, you get true. Easy, right? What happens here? Okay, so the result of this is false, right? Because it has to both be true to be true, so it's false. Then you flip it. So you flip this to and you get. Cool? All right. Oh. Okay. So remember, whenever you see, okay, good. Okay, listen. This is very important. Whenever you guys see a big complicated problem, first, don't freak out. Second, remember, solve it in little parts. A little bit at a time. So the first part we'll solve is just this. What does this mean? Yeah, it means flip what's there. And so it rotates, so we get false, right? So the result of this is false. So now treat this one as false and do false and false. False, right? So then all of this becomes false and you do false or false. False, right? It's the only time where the or operator will give you false, is if both sides are false. The result being false. Wow, we have a lot of these. Okay, solve for this one. Okay, let's go through this. We flip this one, this becomes true. We flip this one, this becomes false. So we have true or false. What is true or false? True. So all of this becomes true. True and true is very nice. Woo! Okay, what's this one? We flip this one. This becomes true. We flip this one. This becomes false. This, therefore, is false. True or false is... Let's have a change in true. Okay, this is interesting. You can do this as much as you want. The first one will go from here to here. The second one will flip it again. So you get false. So what happens here? Okay, so this will turn it into true. This will turn it back to false. You see? You flip it from here to here, then you flip it back. So false and anything is going to give you false, of course. False.
If the number is odd, it will be true. It is open.
Okay, I got a few truths, a few falses.
Equal.
All right. Okay. Let's break this down. What is the result of that? True, right? Because this becomes that. So then, true, we flip again and we get. Then we take that false and we flip it again and we get true. Okay, so all of this is true, right? Okay, so it's true or something else. Do we even care what this is anymore? No, because one of the sides is true, so or, true or anything is going to give you true. Right? But if you do care, it's, this becomes true, then becomes false again, so it's true or false, giving you true. How about this one? Interesting. Okay, let's go through it. Okay, what is that? True. What is that? And what is that? Okay, so this part, so far we have, whatever. We have true. What is the opposite of no? Yes, right, it's true. True or anything else is going to give you true, right? So the result of this is also true. True and true gives you general. Cool? All right. Boolean logic. Congratulations, you all know Boolean logic. Yay. Okay. Okay, so now in code, right? So wait, hey! Okay, so now we talked about with fingers up and down, right? Well, fingers up and down, that is to say true or false in code, is this, true or false. Notice that we're using the same operators in code. Double ampersand means true and, this means or, and then that thing means not. So let's look at the same thing we just looked at with those Facebook likes and potential dislikes with actual code, right? So in this case, we have true and true, that would give us true. False or true would give us true again. Let's consider what this does. False and true gives, what does just this much do? False. We then flip it and get true. And we get true, right? Okay, now, you remember those comparison operators that we had? Well, those return Boolean values. Like 5 is equal to 1 will return a Boolean value. Is this true? Is 5 equal to 1? Yes or no? Well, we know that it's no, right? So this turns into false. And false and true gives you false. That's how that works. Okay, now instead of just writing values, let's create a variable. Let's just call it num1 because it doesn't really serve a function. And let's give it an 8. And let's see if 5 is equal to the value that's inside of num. This will give you false. If this was 8, that would give you true and true. True and true is true, right? Here's an interesting one. Let's have this one. For now, let's just call it B because it's just an example. Let's make it true. Then, let me break code. Okay, so it doesn't print, so you don't have an answer. And then here, let's say not B. Once I delete all this crap that I put here, what will print down here?
False. Num1. There's no num1. Num1.
Wait. Sorry. Yes. Okay. Why? Because if this was true, this much will turn it to false. That much will turn it to true. That much will turn it into false. That much will turn it back into true. And then that, of course, will turn it into false. Make sense? Is the text big enough? Can you guys read it back there? Let me make it bigger. Okay. Does that make sense? Okay, so let me give you guys an example. Let's say we still got a few minutes, wait. Const A is, 5. Const B is, 9. Const C is 99. Okay, don't name your variables like this. I'm just naming it because it's literally just a random example. Then we console.log. A times 2 is equal to 28, or, wait for it, let me put all this stuff in parentheses, or C minus 87 is equal or is not equal to 1. Okay, and let's take all of that. Oops, you didn't just see that. No. Take all of that and C is equal to 99. Yeah. Lousy editor, always printing the answer. Okay, so it's true. So you guys can see how you can chain these pieces of logic, these Boolean expressions together using this and, or, and not to produce a fairly complicated situation. An example of when you might want to do this. Suppose someone logs into your website and gives you some username and password. And you know that the password is, AUA amazing 123. Okay. You can compare their password to that string using triple equals. And if it's true, that is to say the two are in fact equal, right? You know that you can let them into your website. You can give them access to all the things that you want to give them access to. If it's not, if it's false, then you know that you should probably not let them into your website because they wrote the wrong password, right? So you guys can kind of see where Boolean logic can come into play there. So hang on, let me just see 1 second. Okay, I think that's enough for today. Thank you so much. Don't leave.